Every login system, every game, every recommendation engine, every AI assistant, they all rely on one thing: decisions. Right now, millions of software systems around the world are making choices. Should this user be granted access? Should this ad be shown? Should this transaction be approved? The answer to each question shapes what happens next. And it all starts with conditional logic. Imagine a robot standing at a massive crossroads. Multiple routes appear in front of it. Each route represents a different outcome. This is conditional logic, the ability for a program to evaluate a situation and choose what happens next. Without it, software would be trapped in a single, unchanging sequence. No flexibility, no intelligence, no power. The if statement is the foundation of all conditional logic. It works like a security checkpoint. A condition scanner activates. If the condition is true, the gate opens and code executes. If it's false, nothing happens. The program simply moves on. Simple, powerful, and the starting point for everything that follows. But here's the problem. What happens if the condition is false? With just an if statement, nothing happens. The program moves on. But in the real world, we often need to handle both outcomes. A backup plan, an alternative action. That's where else comes in. The if-else statement creates two paths, one green, one red. If the condition is true, take the first path. If the condition is false, take the second path. Now our security gate has two outcomes: access granted or access denied, login successful or password incorrect. Every decision gets handled. No blind spots. If-else works great for binary decisions. Yes or no, true or false. But what if you need to sort something into multiple categories? A child, a teen, an adult, a senior. You can't do that with just if and else. You need more options, more branches, more control. Imagine a massive sorting center. Items come in, they're scanned, and sorted into different bins based on their properties. That's what elif does. If age is less than 13, print child. Elif age is less than 20, print teen. Elif age is less than 60, print adult. Else, print senior. Think about what we've built. A single if statement, a binary if-else choice, a multi-way elif sorter, each one more powerful than the last. But we're not done yet. Sometimes, decisions require multiple layers. Checks within checks. Filters within filters. That's where nesting comes in. Some decisions require multiple checks. Imagine a high-security facility. To enter, you pass through checkpoint 1. If you're 18 or older, you proceed. Then checkpoint 2. If you have a valid ID, you enter. Nested conditions let you stack requirements. Layer by layer. Filter by filter. Only those who pass every test make it through. Sometimes you need to choose between many exact options. A user types a command. Start, stop, pause, reset. Each command triggers a different action. You could write a long chain of elif statements. But there's a cleaner way. The match case statement. It compares one value against multiple patterns, finds the match, executes the code. Fast, readable, elegant. Let's build something real. A login system. The user enters a username and password. First check. Does the username exist in the database? If no, print user not found. If yes, second check. Does the password match? If no, print incorrect password. If yes, print login successful. 3 outcomes. 2 nested conditions. 1 secure system. Online stores make pricing decisions constantly. A customer adds items to their cart. The system checks their membership level. If they're a VIP member, apply 20% discount. If they're a premium member, apply 10%. Else, no discount. The price updates instantly. The customer sees the result. Conditional logic powers the entire transaction. Games use conditional logic everywhere. A player's score increases. The game checks milestones. If score is greater than 1,000, unlock bronze badge. If score is greater than 5,000, unlock silver. If score is greater than 10,000, unlock gold. Each achievement triggers instantly. Motivation, feedback, reward, all driven by conditions. Let's combine every concept. We're building a movie ticket eligibility system. First, check age. If age is less than 13, child ticket, $5. Elif age is less than 60, adult ticket. Then check if it's a weekend. If yes, add $2. If student ID is valid, subtract $1. Multiple conditions. Nested logic. Real-world pricing. All in one system. The conditionals you just learned power everything. Netflix checking if you like a show. Your bank approving a transaction. Google Maps choosing the fastest route. AI assistants deciding how to respond. Every interaction, every recommendation, every decision. It all traces back to if, elif, and else. Simple syntax. Infinite applications. Programs can now make decisions. Choose between paths. React to conditions. But they're still limited. What if a program needs to repeat an action? Check 1,000 users. Process 1,000,000 transactions. Scan through endless data. You can't write 1,000 if statements. You need automation. You need iteration. You need loops. You've learned how software makes decisions. Next, you'll learn how software repeats actions. For loops, while loops, iteration, automation, the power to process millions of items with just a few lines of code. Decisions gave your programs intelligence. Loops will give them scale. Let's begin.